All right. This is just more review. I made this review when I switched and made this just chapter 5 instead of 5 and 6. So this is more prep for the kinds of derivatives and integrals that we'll see. All right. So find f prime of x. So this f prime, the rule for natural log of u is that it's 1 over u times u prime. So 1 over x squared plus x minus 7 times the derivative of that is 2x plus 1. Clean that up a bit. So 2x plus 1 over x squared plus x minus 7. For the next one, e to the cosine of 2x. So the derivative of e to the u is e to the u times u prime. So what is the derivative of cosine 2x? Well, the derivative of cosine is negative sine 2x, and the derivative of 2x is 2. So you've got chain rule to do in there. I'm going to clean this up a bit. I'll make it negative 2 sine x, negative 2 sine 2x times e to the cosine 2x. Another natural log. So we have f prime is equal to 1 over secant x. The derivative of secant is secant x tangent x. The secants cancel out, so f prime of x would just be tangent x. All right, derivative of an exponential. So base a to the u. The derivative is a to the u times natural log of a. So this derivative, f prime of x, will be equal to 5 to the 4 minus 3x times natural log 5. And then we need to remember u prime. Derivative of 4 minus 3x is negative 3. So I would make that negative 3 natural log 5 times 5 to the 4 minus 3x. You don't have to reorder it. I just, that's usually what I do, especially if we're going to be like, multiple choice questions. You might be finding these values and then plugging something into them or, something like that. Number 5, there was something like this on the old quiz. You definitely don't want to make this 1 over this ugly fraction and then do this terrible quotient / product rule. So instead, you want to expand. So this is shown up on quite a few homeworks now. We did this in homeworks, in notes, on the old quiz, on this review. So that's a pretty good hint that there might be something involving you needed to expand logs. And I forgot, speaking of expanding logs, I put an extra problem on the key, didn't I? So let's grab that problem. I want to talk through this one. So let me just grab it, copy it, paste it. Oh, come on. Let me try pasting it up here. I mean, really, I could have just written it out at this point. Okay, there we go. No, it was good. All right, so I made this extra problem because, again, we have talked about this. We did this in our notes. It wasn't super prevalent on the homework, though, so I wanted to make sure we brought it up. You will need to be able to take the derivative of something that's not a natural log. The problem is we only have a rule for derivatives of natural logs, but change of base formula is how we get something that's not a natural log to be a natural log. So change of base says that I can rewrite this as y equals ln of x plus 2 divided by ln of 3. That's equivalent to the log base 3 of x plus 2. And now dy dx should be easy to find because ln 3, 1 over ln 3, that's just a constant. And then what's the derivative of ln x plus 2? 1 over x plus 2 times 1. But that's it. And then I can work with this thing. I can set it equal to things. I can plug numbers into it, whatever else I might need to do. But this is something like this is on the test. Okay. Back to this one. Sorry, that triggered my mind there to remember that. So I need to expand f of x before I start taking derivatives. So this would be the natural log of x cubed, which is 3 natural log x, plus the natural log of square root of x plus 1, which is 1/2 natural log of x plus 1, minus the natural log of 2 minus x squared, so minus 2 natural log of 2 minus x. Now f prime is much easier to find. Derivative of 3 ln x is 3 over x. This becomes 1 over 2 times the quantity x plus 1. Parentheses matter here. I've noticed some of you are dropping parentheses. I don't know if you're getting lazy about it or if you don't know. But when you multiply quantities together, you need parentheses because 2x plus 2 is different than 2x plus 1. And then here, minus 2 over 2 minus x. But this is the only one that the derivative of the inside is not just 1, like these other two. So the derivative of 2 minus x is actually negative 1. So that's going to be plus. So 3 over x plus 1 over 2 times x plus 1 plus 2 over 2 minus x. Number 6 needs a product rule. We had something like this on our short quiz. So f prime is the first times derivative of the second. Derivative of this is e to the negative 5x times negative 5 plus the second times the derivative of the first. All I'm going to do with this right now is clean it up a bit. So negative 5x cubed e to the negative 5x plus 3x squared e to the negative 5x. Yes, I could factor this a bit, but if we're just told to find the derivative, there's no point in simplifying it further. All right, now on to antiderivatives, so integrates. All right, so again, I have not memorized, I was just saying this on the old quiz, I have not memorized the integral of tangent. I know I can probably puzzle through it now. It's negative natural log of cosine x, but like I said, I'm never confident. I've never bothered to learn it because I can always just do this one. So I'm not going to give you anything other than the integral of tangent or cotangent or sine or cosine. So secant and cosecant are the only ones that are not easily u-subbed to figure out. And I don't think the AP test will either. So all of that is to say, I'm going to do it the long way. So u is 3x, du dx is 3, du divided by 3 is dx. So begin by saying, all right, this is the integral of, instead of tangent, I need to make it sine of u over cosine of u. And then dx is going to be du divided by 3. So I'm putting a 1/3 out here. Now, I need another round of u sub, but I really shouldn't use u again. So I'm going to use w. Use whatever you want. But w is going to be cosine of u. I'm going to dw du. That's negative sine of u. Solve for du. So now what do I have? Now we have this 1/3 out here. The integral of sine of u. I replaced cosine u with w. And I want to swap out du for dw over negative sine u. So sines cancel. Negative comes out here. Negative 1/3 times the integral of 1 over w dw. That's negative 1/3 times the natural log of the absolute value of w, which is cosine of u, but u was 3x. So if you just had it memorized, that's fine. If you know that I was right, it was negative natural log of cosine u plus c, but you still have to do the red u sub part. Even if you have it memorized, you would make it 1/3 tangent u du. You do have to do that. All right, so let's look at it if I just memorized it. I did it the long way on the key that I posted, but let's just go ahead and okay, what if we memorized it? Because now that I see this one, I kind of know what this one is. So u would still be 2x. Du dx would still be 2. Du divided by 2 would equal dx. So this would be cotangent of u. Instead of dx, I'd have du over 2, or just put a 1/2 out in front. And then suppose we just have this memorized. This is 1/2 times the natural log of the absolute value of, what would its denominator be? Sine. So sine of 2x plus c. If you want to memorize the formulas, go right ahead. It's just there are a handful of things we need to memorize for calculus, so I don't allow these two memorizations to take up any of my brain space, but you're welcome to. All right, if you want the long way, see the Post-it answer key for how I did that. It's similar to this. All right, number 9, u is the exponent, so u is cosine x. Du dx is equal to negative sine x. That means du divided by negative sine x is equal to dx. Sub in what we have, so we have e to the u. There's a sine x here, and then dx is going to get replaced with du divided by negative sine x. So the signs cancel. The negative is going to get pulled out. Negative integral e to the u du is equal to negative e to the cosine x plus c. We had something like this on the old quiz, right? So, all right, so what happens here? This is not inverse trig. It is u sub, although du dx is 1. And so putting in a u in the bottom and a 1, or I mean a du for the dx is not going to get rid of the x plus 2. But remember the trick that we used was to solve this equation for x. So u minus 3 equals x. Now I want x plus 2, so I can say, all right, x plus 2 then. If I add 2 to the right side, I add 2 to this side. X plus 2 will be u minus 1. Or you could do, u minus 3 plus 2, u minus 1. So now it's u minus 1 on top over u on the bottom, du here. Hart method this thing. So this is 1 minus 1 over u, du. And I'm going to leave mine in terms of u, so it's u minus ln absolute value of u plus c. U was x minus 3 minus ln x minus 3 plus c. Now, if you split this up into integral of x dx minus 1 over u du, then this would just become, or sorry, not x dx, integral of just 1, but you kept this dx and you made this du. This is also correct. X minus ln absolute value x minus 3 plus c. This is correct because mine is just a vertical shift down 3 units compared to yours. So remember, the plus c can be any vertical shift. So these are equivalent answers. I would take either one. All right, for this one, u is equal to 5x. Du dx is equal to 5. Du divided by 5 is equal to dx. So this is the integral of 3 to the u du divided by 5. So put a 1/5 out there. 1/5 times 3 to the u divided by natural log 3 plus c. When I integrate base a, any base other than e, I'm dividing by natural log of that base. All right, for this one, u is equal to 4x. Du dx is equal to 4. Du divided by 4 is equal to dx. And you can take this 2 out in front if you want to. It's e to the u. Du divided by 4, let's put that out here. So we have 1/2 times the integral of e to the u du. That's 1/2 times e to the 4x plus c. And that's it. Technically, there's a divided by ln e in there, but that's just 1. So that's why we don't show that for these. But we do show divided by ln 3 for something like 11. Okay, ignore that extra problem. Arctan and arcsine. So I talked about this on, did I? Yeah, on the old quiz. You can either memorize the formula or you can do the triangle way. I will show you both. So formula first. You only have, out of the 6 formulas that there are, out of the 6 formulas that there are only 2 that I'm telling you to memorize, which are arc, tangent, and arcsine. So what is the formula? It's the derivative with respect to x of arc tan of u is equal to u prime over 1 plus u squared. And so in this case, u is 4x. Du dx, which is u prime, is equal to 4. And so my answer would just be 4 over 1 plus 4x, the quantity squared, is 16x squared. That's it. That's the answer for dy dx, or f prime, I should say. The triangle way is to say, okay, this is y equals arctangent of x. I'm going to take the tangent of both sides, so tangent of y equals 4x. I'm going to set up a right triangle where y is the angle, opposite y is 4x, adjacent to y is 1. And then I'm going to Pythagorean theorem to get the hypotenuse. And then I take the derivative with respect to x of both sides of this equation. The derivative of tangent is secant squared y, dy dx, chain rule. The derivative of 4x is 4. We can divide by secant squared, or dividing by secant squared is the same as multiplying by cosine squared. And now you don't want to leave this in terms of y, so come over to your triangle. The reason this triangle exists, because you haven't used it yet, the reason this exists is because you can find the cosine of y. It's adjacent over hypotenuse. And we don't want cosine y, we want cosine squared y. So square 1, square a square root. And you will see how you got 4 here times 1 over 1 plus 16x squared. Same exact answer as I got before, a lot more work. Okay, what is the formula then for the derivative of, with respect to x, of arc sine of u? That is equal to u prime over square root of 1 minus u squared. In this problem, u would be x to the 1/3, cube root of x. Du dx, or u prime, would equal 1/3 x to the negative 2/3. So I'm going to put that down here. And so according to the formula, it's u prime 1 over 3x to the 2/3 over the square root of 1 minus u x to the 1/3 squared. Let's clean this up a bit. So bring the denominator up here down. 1 over 3x to the 2/3. And then square root of 1 minus squaring, power to a power here is multiplying, so this becomes x to the 2/3. So that would be your f prime of x equation. I get that same thing doing the triangle method. So if y equals arc sine of cube root of x, then, let's do this. Then sine y equals cube root of x. I'm going to do x to the 1/3 again. Set up a triangle. Y is here. Opposite is x to the 1/3. Hypotenuse is 1 because it's over 1. Pythagorean theorem, hypotenuse squared minus leg squared. And again, squaring x to the 1/3 becomes x to the 2/3. Take the derivative with respect to x of sine y, and take the derivative with respect to x of x to the 1/3. The derivative of sine is cosine y, and chain rule, dy dx. The derivative of x to the 1/3 is 1/3 x to the negative 2/3, so we'll put that down here. Cosine of y, I can get that value for my triangle. It's adjacent over hypotenuse, so it's just 1 square root of 1 minus x to the 2/3. And I'm going to divide that over to the other side. So see how I end up in the same spot? And then, of course, we'll clean that up. 3x to the 2/3 square root of 1 minus x to the 2/3. It doesn't matter to me which method you do. Obviously, if you're worried about time, it's worth your time before the test to memorize these two formulas. All right, what about f inverse? So, and number 16 got cut off. I believe this is 11 here. All right, so on 15, we want f inverse prime at c. So we want to find f inverse prime of 4, which means step 1, set f of x equal to 4 and solve for x. So square both sides to get rid of the square root. Add 8. Divide by 2. Step 2 is find f prime of x, and then we're going to plug in 12. So this is 2x minus 8 to the 1/2. So it's going to be 1/2 times 2x minus 8 to the negative 1/2 times derivative of 2x minus 8. So f prime of 12, 1/2 times 2 is gone. It's 1 over the square root of 2 times 12 minus 8. That's 1 over the square root of 16. So that's 1/4. And then to get the final answer here, f inverse prime of 4 is equal to 1 over f prime of 12. That's 1 over 1/4, which is equal to 4. Same steps, just different numbers for the next one. So step 1, I want to find, because I want to evaluate f inverse prime at 11, I want to set f of x equal to 11 to see what the reflected point is going to be. Get this equal to 0, solving a quadratic. Factor. Solve. Now, you don't really have two answers because x has to be greater than or equal to -1, so we're throwing out -4, going with 2. So step 2 is to find f prime of x and then evaluate it 2. So that's 2x plus 2. F prime of 2 is equal to 6, right? 2 times 2 plus 2, yep, 6. And step 3 is to say f inverse prime of 11 is equal to 1 over f prime of 2, which is 1 over 6. Okay, last problems. Integration. So again, you might have stuff like this on your problems where you just have to integrate, right? I have 3 problems where you're just integrating. All right, so I see a constant over a sum of squares, so that yells arctan to me. So a is equal to 2, u is equal to x, du dx is equal to 1. Let's take the 8 out in front. So yeah, it's 1 over a squared plus u squared du. Formula for this is 8 times, this is arctan, so times 1 over a, arctan of u over a plus c. 8 times 1/2 is 4, arctan x over 2 plus c. Remember that arctangent is the same as inverse tangent. So if you want to use that notation, you can. All right, number 18. This looks like arc sine. And the reason there's still an x up here is because I have something higher than just x squared. So this is probably going to work out okay. Let's check. So a would be 3. U would be square root of 4x to the 4th, so 2x squared. And then, yeah, du dx is going to be 4x. So we have the x. We want to get 4x here. So I'm going to keep using my substitution thing. I don't want to lose anybody. So what do we have here? We have this x on top, which we're hoping will cancel. Square root of a squared minus u squared. Dx is du over 4x. So yeah, that x cancels with that one. There's a 1/4 out in front of my setup for inverse sine. All right, so the inverse sine formula does not have a 1 over a out in front. So it's 1/4 arc sine of u over a, so 2x squared over 3 plus c. What about this one? When exponentials are involved, u is always going to be the exponent. So u is going to be radical x. Du dx is going to be, so this is x to the 1/2. So 1/2 x to the negative 1/2, which puts radical x in the bottom. That means that you'll multiply 2 radical x over here times du to get dx by itself. So if you're setting this up, you've got 5 to the u over this radical x, which you hope will cancel. Dx is now 2 radical x du. So yeah, that radical x cancels with that one. There's a 2 out in front. And then when I integrate a base other than e, it's 5 to the u, so 5 to the radical x, over ln 5 plus c. Okay, so that finishes up our Chapter 5 review. Remember, if you haven't looked at the AP Classroom yet, that's a good way to practice multiple choice questions. You should be able to start, do some of them, stop. It should grade as you go. So consider looking at that if you haven't been using those. They, I think, are usually pretty helpful.